All. In this lecture, we will discuss about the domain of dependence and region of influence of the Cauchy problem for the one-dimensional wave equation. For that, consider the Cauchy problem utt minus c square uxx equal to 0 for minus infinity less than x less than infinity and t greater than 0 and with the initial conditions u at x0 equal to fx and ut at x0 equal to g of x where minus infinity less than x less than infinity. Now let's examine what is the information that actually determines the solution u at a fixed point x0 t0. So let us take one fixed point, let x0 t0. So let x0 t0 be a fixed point. Now consider the xt plane and the two characteristics passing through the point x0 t0. We know that for the one-dimensional wave equation, the characteristics are given by x minus ct equal to a constant and x plus ct equal to another constant. So the characteristics passing through the point x0 t0 are given by x minus ct is equal to x naught minus ct naught and x plus ct is equal to x naught plus ct naught. This can be seen in the figure. Uh, the two red lines represents the two characteristics x plus ct equal to x naught plus ct naught with the negative slope, and the line x minus ct equal to x naught c naught is this is the line with a positive slope, and x naught t naught is the point. This is the point x naught t naught, and we can see that the two characteristics intersect the x-axis at the points x0 minus ct0 and x0 plus ct0. That is, the characteristics intersect the x-axis at the ordered pair x0 minus ct0 0 and at x0 plus ct0 comma 0. And one more thing we can notice is that there is a triangle formed here. There is one triangle is formed with like this. So whose vertices are the three vertices are the characteristics vertices of the characteristics, and the base x, the interval closed interval x naught minus ct naught to x naught plus ct naught. So the triangle is formed by the characteristics and the interval, closed interval x naught minus ct naught to x naught plus ct naught, and this triangle is known as the characteristic triangle. So the characteristic triangle is the triangle formed by the two characteristics at the point x naught t naught and the interval, the base of the triangle in the interval, closed interval x naught minus ct naught to x naught plus ct naught. This is the characteristic triangle. Now we may calculate or we may find the value of u at the point x naught t naught, and we have by D'Alembert's formula it is given by u at x naught t naught is equal to 1 by 2 f of x naught plus c t naught plus f of x naught minus c t naught plus 1 by 2 c integral x naught minus c t naught to x naught plus c t naught g of s ds, where f and g are the initial data which are given. Okay. So from this formula itself, it is clear that the value of u at the point x0 t0 is determined by the two functions f and g that are the initial data, and f depends only on the points x0 plus c t0 and x0 minus c t0. So that means which are the vertices of the characteristic triangle, isn't it? Vertices of the characteristic base, and the function g is integrated along the interval x0 minus ct0 to x0 plus ct0. So the function, the value of the solution or the solution at the point x naught t naught depends only on the vertices of the characteristic base, that is at the points, the value of f at the points x naught minus c t naught and x naught plus c t naught, and the value of the function g in this interval, that is closed interval x naught minus c t naught to x naught plus c t naught, and which doesn't depend on another or the value of f and g on any points at any point outside this interval. It just depends on only this interval. Okay. Um, that means the value of u at the point x naught t naught is determined by the values of it is determined by the values of f at the vertices of the characteristic base and by the values of g along this characteristic base. Or we can say that u at x naught t naught depends only on the part of the initial data which is given on the interval x naught minus c t naught to x naught plus c t naught, isn't it? Only this the part of the values of f and g only in this interval. Actually f we need to find f at the endpoints of this interval and g is along this interval throughout this interval, that is we needed to find u at x naught t naught. So this interval, the set of all points or this interval in the set of all points in this interval is known as the domain of dependence of u at the point x naught t naught. Domain of dependence of u at the point x naught t naught. Okay. Hence, if we change the initial data in the interval outside this domain of dependence, it will not affect the solution at the point x naught t naught. Okay, that because by the formula itself, it is very clear. That means if we change the initial data outside, initial data means the values of f and g outside the interval outside the interval means the domain of dependence x naught minus c t naught to x naught plus c t naught in this interval. Uh, the solution of u at the point x naught t naught will not change because this is because we know that the information on a change in the data travels with a speed of c along the characteristics, and therefore such an information is not available for t less than or equal to t naught at the point x naught. Now let this be the point x naught. So and this is the point t naught. Okay, and we can see that any change in the initial data will travels along the characteristic lines, the two characteristic lines, and for any point t less than t naught, that is for any point here, there is no information available, isn't it? Because the change will happens only through the travels along the characteristic curves. So this is because the if we change any value, there is a change in any initial data, it will not affect the value of the solution. The solution u at the point x naught t naught. Okay. Hence, for every point xt in a fixed characteristic triangle, uxt determines the is determined only by the initial data given on the characteristic base. Okay, that means any point for every point xt in a fixed characteristic triangle, uxt is determined only by the initial data that are given on the characteristic base, isn't it? That is, it is given on this base. It depends only any point for any point xt in this characteristic triangle of the fixed point x naught t naught for any u of xt, it depends only on the points that are in the characteristic base. Okay. So furthermore, if the initial data are smooth on this base, then the solution is also smooth on the whole triangle. So we have this triangle, um, this triangle which is the characteristic triangle of the point x naught t naught, of the fixed point x naught t naught, and we know that the value for any x and t, u at xt will depend on the value of the initial data along the characteristic base. Characteristic base means in this interval, closed interval x naught minus c t naught to x naught plus c t naught. Okay. So the initial data, if the initial data are smooth on this base, if the initial data is smooth on this base, then the solution will also be smooth in the whole triangle, because it depends only the value of u at x naught t naught or u at xt in this characteristic triangle depends only on the value in this characteristic base. So in this characteristic base, if the initial data are smooth, then the solution will also be smooth on this whole triangle. Um, Thus, we may conclude that for a fixed point x naught t naught, there is a triangle that is known as the characteristic triangle, and such that for any point in this triangle xt, the initial data, the u of xt, the solution at any point inside this characteristic triangle, is determined only by the initial data that are given on the characteristic base, closed interval x naught minus c t naught to x naught plus c t naught. Okay. So naturally there may arise another question or the opposite question. That means for any interval, for a fixed interval, closed interval AB, closed interval AB, which are the points on the half plane, that is this is a half plane t greater than 0. So which are the points on the half plane that are influenced by the initial data, influenced by the initial data on a fixed interval, closed interval AB. So it is natural that such questions may arise. So now we need to find or determine the idea of that one, that is for a fixed interval, closed interval AB, which are the points on the half plane t greater than 0 that are influenced by the initial data on a fixed interval, on that fixed interval, closed interval AB. And such points, that is the set of all points on the half plane t greater than 0 which are influenced by the initial data on a fixed, on this fixed interval, is called the region of influence of the interval, closed interval AB. So the region of influence means of a fixed interval, closed interval AB means for a fixed interval, closed interval AB, the set of all points that are in the half plane t greater than 0, that are in the half plane t greater than 0, which are influenced by the initial data on this closed interval AB. Okay, that is the region of influence of this closed interval AB. And from the above discussion, it follows that the points on this interval will influence the value of the solution at the point x naught t naught. We know that u at x naught t naught is a fixed point, and the solution at x naught t naught, and solution u at the point x naught t naught depends only on the initial data that are defined on the characteristic base, which is given by closed interval x naught minus c t naught to x naught plus c t naught. So the value of u at the point x naught t naught will depend on the influence of the initial data on this interval characteristic base. Okay, and we know that the points on the interval, on this interval, that means in the closed interval AB, and the points on the closed interval AB will influence the value of the solution at the point x naught t naught, if and only if it will, that means the points on the interval closed interval AB will depends on the value of u at the point x naught t naught, if and only if the two and this will depends on the interval, the values of the initial data on this interval x0 minus ct naught to x0 plus ct naught. So the points in this interval, closed interval AB, will influence the value of u at x0 t0 if and only if we can have if and only if the closed interval AB intersection has a non-zero intersection, isn't it, or non-empty intersection with the characteristic base, that is x0 minus ct naught to x0 plus ct naught. Okay, so that is explained here. So I'm not writing this one here. Okay, so the values of the points of the interval, closed interval AB, influence the value of u at a point x0 t0 if and only if the intersection of the two closed intervals, that is closed interval AB and interval closed interval x0 minus ct0 to x0 plus ct0 is not equal to 5. Okay. Thus, the set of all points on the half plane t greater than 0 that are influenced by the initial data on this fixed interval, closed interval AB, is known as the region of influence of this interval, that is the closed interval AB. And we can see that the points on this interval of influence, the region of influence, is the value of the solution or influence the value of the solution u at the point x0 t0 if and only if the intersection of the two intervals, that is the closed interval AB and the closed interval x0 minus ct0 to x0 plus ct0 is non-zero or is non-empty. That means the initial data along the interval, closed interval AB, influence only the points xt satisfying the equations or inequalities x minus ct less than or equal to b and x plus ct greater than or equal to a. So we have from this figure, that is figure 2, we can see that this is the line x plus ct equal to a, and the region where x plus ct is greater than a is belong to greater than a means it belong to this side. Okay, so this is the region where x plus ct is greater than or equal to a, and this is the line x minus ct. This is the line x minus ct equal to b, and x minus ct is less than or equal to b means it includes this region. So these are the two inequalities this represent. Okay, so we can see that. So from this figure, it is clear that the region, the initial data along the interval, closed interval AB, influence only the points xt in which x minus ct is less than or equal to b and x plus ct is greater than or equal to a, which are represented by the dotted lines or the split lines in the region with the yellow lines in the figure. Okay, so these are the points. So the region of influence means these are the points inside this truncated characteristic cone or forward characteristic cone that is defined by the base. Here the base is the closed interval AB and the edges x plus ct, that is x plus ct equal to a and x minus ct, x plus ct equal to a and x minus ct equal to b. So the points in the region, in this region that are influenced by the characteristics influenced by the points xt, which satisfies x minus ct less than or equal to b and x plus ct greater than or equal to a, are the points inside this truncated cone, characteristic cone, which is defined by the base closed interval AB and the lines. We can see this. Okay, we can see this one. So these are the region is defined by the lines or the characteristics x plus ct equal to edges, x plus ct equal to a and the base, characteristic base, closed interval a, b, and the line x plus ct equal to x minus ct equal to b. So the region is inside this characteristic cone. That is, it is the union of the four regions which are explained, numbered as 1 to 4. So the region of influence is the set of all points in the union of these 1 to 4 regions. Okay. Now if we check what happens whether the initial data f and g vanish outside this interval, closed interval AB. So if we assume that the initial data f and g, that means the values of f and g are equal to 0 outside the closed interval, closed interval AB. Then the amplitude u or the solution u of the vibrating string is 0 at every point outside the influence region of this interval. So we can see that if the initial data f and g vanishes outside this interval, then the solution also, the amplitude of the vibrating string is also become 0 at every point outside the influence region of this interval. Or on the other hand, for a fixed point x0 on the string, if we fix a point x0 on the string, then the effect of perturbation along the interval, closed interval AB, perturbation means a small change. So when we change the effect, when we it is changed, or for a fixed point x0 on the string, the effect of perturbation along the interval, closed interval AB, will be felt after a time t0 greater than or equal to 0 and eventually, and for t large enough, the solution takes the constant value. Okay, for t is larger, then the solution takes the constant value u at x naught t is equal to 1 by 2c integral a to b g of s ds. So, if there is a change in the value interval along the interval xab and x0 is a fixed point on the string, then the effect of this perturbation will be felt after a time t0 greater than 0, and when t is increasing largely or t is large enough, then the solution may have the form, the constant value will take the constant value u at x naught t is equal to 1 by 2c integral a to b g of s ds. This is because we know that u at by the formula we have u at x naught t. U at x naught t is 1 by 2 f of x naught plus ct plus f of x naught minus ct plus 1 by 2c integral x naught minus ct to x naught plus ct g of s ds. So this is the value of u at the point x naught t. So when t becomes large enough, so let this in the figure, let this be the point x naught, and when t is large enough, then x naught minus c t naught, what happens to x naught minus t naught? So when t is large enough means as t tends to infinity, x naught minus c t naught tends to minus infinity, and x naught plus c t naught tends to plus infinity. Okay, so that means x naught minus ct will be less than a and x naught plus ct will be greater than b, isn't it? As t becomes large, this will be minus infinity, which is less than a, and x naught plus ct will be greater than a. Okay. So we can have f, and we have already assumed that f and g vanish outside this interval AB, closed interval AB, and we can have f of x naught minus ct is less than a, which is outside the interval, and x naught plus ct is greater than b, which is also outside the interval. So f at these 2 points will be equal to 0. So this will be 0. So the only thing remaining is 1 by 2c integral x naught minus ct to x naught plus ct g of s ds. So this will be integral minus infinity to infinity g of s ds, which can be splitted as minus infinity to x naught minus ct plus x naught minus ct to x naught plus ct plus x naught plus ct to infinity, like this. So and we know that from minus infinity to x naught minus ct value is 0, and non-zero value is attained only in this interval, that is x naught minus ct to x naught plus ct. Okay, so we have or we can have this is equal to that means the solution at x naught t is equal to 1 by 2c integral sorry, not x naught minus ct, we have up to what, ab. We know that f and g vanishes outside the interval, closed interval ab. So we have to split the integral like that. So integral minus infinity to plus infinity, we can split it as integral minus infinity to a, then a to b, plus b to plus infinity. So minus infinity to a and in b to infinity, g of s is g is 0, g vanishes, and hence we have the non-zero value only in the interval closed interval ab. So we have the solution u at x naught t is equal to 1 by 2c integral a to b g of s ds. Okay, so this about the solution at a fixed point x naught inside this interval. So and this occurs, and we can see that this occurs when at the points x naught t that are inside the cone, and inside the cone, which cone, x naught minus ct, we have obtained the two conditions, x naught minus ct less than or equal to a and x naught plus ct is greater than or equal to b. So we can check this region x naught minus ct, x naught minus ct less than or equal to a, isn't it? That means this region, x naught minus ct less than or equal to a. So this will be that region, and then x naught plus ct greater than or equal to b, that is this region. That means these are the points inside the region 4. Okay, that is region inside 4, or the region 4 includes these points. Okay, so this is about the nature of the solution at a point, at a fixed point x naught t naught, and also in the any interval the solution at a ux naught t, any interval for a closed interval ab, the solution at any point x naught is in this form, 1 by 2c integral a to b g of s ds. Okay, let's stop here. Thank you all.